Hello my dear children. So yesterday we were doing Raoult's law, that is vapor pressure, liquid in liquid. Let us start today with the vapor pressure of solid in liquid. Write down again Raoult's law, continue solid in liquid. It's very interesting topic today. Now solid in liquid, make two beakers. Along with me, hope you have opened NCERT. Open the page where there is two beakers are drawn. Make two beakers, solid in liquid. Vapor pressure, you know what is vapor pressure? It is a pressure exerted by the vapor over the liquid surface at equilibrium. System must be closed, otherwise your vapors will get escape. This is your, write down, this is your pure solvent. This is your pure solvent, write down and go writing along with me. Total understanding based all things are. It's a volatile. Volatile means it escapes into vapor. It has a high tendency to escape into vapor. Write down along with me. So these are the vapors going on because it is the pure solid, that is it is volatile. Now close this beaker, otherwise your vapor get escape. This is my closed system, I closed it properly so that the vapors remain inside. Vapors go above. I think you know what's vapor pressure. When the vapors go above, after that condensation start. A stage come when rate of evaporation is equal to rate of condensation, and at this stage the pressure exerted by the vapor over the liquid is vapor pressure. Now this is your volatile solvent. This is my liquid. Let us add solid in it. Now come to the second beaker. This is my second beaker having same solvent. Again the solvent is volatile. System is closed. Make a closed system. Now students, let us add solute in it. That is solid in liquid. Solute, make solute. Dots along with me. This is my solute. Some of the solute particles occupy the surface. And remember and stress on my word, solute is non-volatile. It's a non-volatile solute. Mention it. So when the solute is non-volatile, it's very much clear. It occupies the surface area decreased. Hence, the less molecule of the solvent get a chance to escape into vapor. Now, you can compare these two diagrams. You can see in this diagram so many vapors are escaping. But in this case, less vapors. Why less vapors? Because the solute occupies the surface. Surface area decreased. When the surface area decreased, that decreases the escaping tendency of the vapors. Because solute is non-volatile, it will not go into vapor. It will restrict the motion of the solvent. It will produce interference in the movement of the solvent. That's the reason less vapors. So less vapors, so less vapor pressure. So its vapor pressure is more, its vapor pressure is less. So when you have prepared a solution, the vapor pressure of solution is less. Write down less. Vapor pressure. Vapor pressure of solution is less than solvent. Very important it is. Question may usually come, why the vapor pressure of, I think it's very simple and very interesting it is. Why the vapor pressure of solution get decreased when a non-volatile solute is added to solvent. This is very clear, I think. Now I should go further. So this is, I'm going to rub it, and remember my students, these two beakers will carry on at the end. It will carry on in each topic and it will stop. I will stop teaching these two beakers at the end. This means you make a base. These two beakers are the base of the next topics. Please make the base. Please understand what this is saying. Solute is non-volatile. Solute occupies the surface, decreases the surface area, vapor pressure decreased. Now write down Raoult's law. Derivation of Raoult's law heading. Put a heading. Derivation of Raoult's law. when solute is non-volatile. PS is equal to PA plus PB. Yesterday I discussed. PS is equal to PA plus PB. Write down A is my solute and B is my solvent. Either you write 1, 2, that is your wish. You may write, if anything is in excess, you may write 1. Anything is in less quantity solute, you may write 1, 2. So it's one and the same thing. So PA is equal to 0. Tell me why it is 0. Because because solute is non-volatile. Because solute is non-volatile, it will not go into vapor form. So less the vapors, less the vapor pressure. Hence, solution vapors, total solution, total vapor pressure of the solution are only dependent upon B. B is a solvent. It's Beaker saying. PA is equal to 0. Why PA is equal to 0? Because solute is non-volatile. Solute will not escape into vapor. No vapor pressure exerted by the solute. PA is equal to 0. PS is equal to PB. Put Raoult's law. PB is equal to P naught B XB. This is Raoult's law. PB is equal to P naught B XB. PS is equal to P naught B. XB is 1 minus XA. Open the bracket. PS is equal to P naught B minus P naught B XA. Simplify it. P naught B XA is equal to P naught B minus PS, and this comes XA is equal to P naught B minus PS by P naught B. Now you can see at the end what comes? P naught B minus PS. This is my second beaker. This is my first beaker. P naught B is the first beaker. Vapor pressure of the solvent is more. Vapor pressure of the solution is less. This is my lowering vapor pressure, delta P. Vapor pressure get decreased. Why? Because of XA. A is a solute. Vapor pressure get reduced, delta P by P naught B. Arrive delta P is a lowering in vapor pressure. This topic will again come in the next lecture. We will take again. Lowering in vapor pressure. Lowering in vapor pressure, delta P proportional to XA. Second beaker. The vapor pressure of the solution is less. Vapor pressure of solution is less. Vapor pressure of solvent is more. This means it comes delta P. Delta P is a lowering in vapor pressure. And the lowering in the vapor pressure is directly proportional to the mole fraction of the solute. More the solute you will add, just it's rough work. This is my solvent. More the solute you will add, more the surface get occupied. More the surface get occupied, less the chances of the solvent molecule to escape into vapor. Less the vapors, less the vapor pressure. That means lowering in vapor pressure is directly proportional to XA, that is mole fraction of solute. This topic will continue in the further topics, that is in colligative property, we will take tomorrow. Now this is all about heading is derivation of Raoult's law when the solute is non-volatile. Next topic, write down. This completed Raoult's law. This completed topic Raoult's law. Now next topic is ideal and non-ideal solution. Ideal and non-ideal solution. Now student, we have discussed Henry's law as well as we have discussed Raoult's law. I told you in my last lecture, Raoult's law and Henry's law, constants only differ. Rest parts are same, because in Henry's law, PA is equal to KHXA, and Raoult's law, PA is equal to P naught AXA, that we discussed. Henry's law and this is Raoult's law. Now Raoult's law, after Raoult's law, the topic is ideal and non-ideal solution. And I told you what is ideal solution. Ideal solution is that which obey Raoult's law under all conditions of temperature, pressure under all concentration which obey Raoult's law, and non-ideal solution which do not obey Raoult's law. Another ideal solution is that where delta H mixing is 0. Ideal solution is that where delta V mixing is 0. Everything very simple topic and very interesting. You just write first. Ideal solution is that where PA is equal to P naught A XA, where PB is equal to P naught B XB, and where PS is equal to PA plus PB. And number 5, ideal solution is that where like and unlike interactions are same. Like and unlike interactions are same. So ideal solution is that very less solutions are ideal. They are nearly ideal. Example, you may write benzene and toluene is nearly ideal. 1 or 2 example you may take the reading from NCERT. One very simple example is benzene and toluene. They are nearly ideal. Otherwise, ideal solutions are very rare. Now this topic, these all things will only then get clear if I take the topic non-ideal solutions. Then it will become very simple for you. First of all, write down this, and now I'm going to start non-ideal solution. The moment I will cover non-ideal solution, all the things will get clear. So ideal solution is that which obey Raoult's law under all concentration, where delta H mixing 0, where delta V mixing 0, which obey Raoult's law. This is Raoult's law. Write down non-ideal solution. Non-ideal solution is that which do not obey Raoult's law, where PA is not equal to P naught A XA, where PB is not equal to P naught B XB, where PS is not equal to PA plus PB, where like and unlike forces are different, where delta H mixing is not 0, where delta V mixing is not 0. Non-ideal solutions are of 2 types. One is non-ideal solution showing positive deviation. The other is non-ideal solution showing negative deviations. Non-ideal solution showing positive deviation, this is common. When I will say positive deviation, you will say PA is greater than, PB is greater than, same. PB is greater than, PS is greater than, this is common. This is common. Like forces, positive deviation. Unlike forces are weaker, like forces are weak. Like forces are weaker than unlike. In negative deviations, PA is less than P naught A XA, PB is less than P naught B XB, PS is less than PA plus PB, and where like forces are weaker but unlike forces are stronger. In case of negative deviations, like force is stronger than unlike. Now one by one I am taking. Write down examples. Non-ideal, first of all write down non-ideal solution showing negative deviations. This is all out, please kindly write. Non-ideal solution is that where PA is not equal to P naught A XA, where PB is not equal to P naught B XB, where PS is not equal to PA and PB, where like and unlike forces are different, where delta H mixing is not 0, where delta V mixing is not 0. And when anybody asks the word positive, you will write greater, greater. Negative, lesser, lesser. I'm taking in detail one by one. Only then the topic gets clear. Write down example. Example. Now I have acetone and chloroform. I've taken 2 components, acetone and chloroform. Write down CHCl3, acetone and chloroform. These are the two components. I don't know why, either it is a ideal solution or it is a non-ideal or it is showing positive deviation, negative deviation. Now understand this topic. The moment I will mix acetone and chloroform, write down acetone, CH3, CO, CH3, acetone, and this is chloroform. Chloroform. When acetone and chloroform are mixed, these are the two components. When I allow them to mix, then write down hydrogen bond formed. Make a bond. Hydrogen bond formed. Because bond formed, energy released. Because bond formation, energy released. After mixing, energy released. Because bond formed. So delta H mixing, after mixing, energy released. So delta H mixing is negative, that is less than 0. Same thing. Because after mixing, bond formed, components come closer. Because bond formed, components come closer. Because components come closer, so delta V mixing decreases. After mixing, volume decreases. You may write less than 0 as well, that is your wish. Because bond formed, components come closer, so volume decreased. Third is, because bond formed, components come closer, attraction takes place. Now these two components less get chances to escape into vapor. These two components get less chances to escape into vapor because bond formed. Let it is A, let it is B. So partial pressure of component A is less than, PA is less than P naught A X A. PB is less than P naught B X B. Same, PS is less than PA plus PB. So remember students, when the two components are allowed to mix, and if there is a bond formation, this is unlike force. Have you noticed this is unlike? Now here like force is weak, but unlike force is strong. Write down number 4. Here like force is weak, but unlike force is strong. So here like force is weaker than unlike. Unlike, right? And this is my 4th point. Understand the topic. Now I'm taking positive deviation example. The moment I will take the example of positive deviation, I think your topic will be totally clear. Again listen, I mix two components acetone and chloroform. The moment I mix two components acetone and chloroform, a bond formed, energy released. Energy release reaction is exothermic. Delta H mixing is negative. Because components come closer, volume decreased. Because component come closer, a force takes place. Molecules get less chances to escape into vapor. Vapor pressure of individual component decreases as well as a total vapor pressure decreases. Now I'm taking my second example. In my second example, I have taken ethanol. Write down along with me, it is ethanol, CH5OH. Ethanol has already H bonds. CH5OH, it has H bond. CH5OH, draw it along with me. So on, H bond. This is ethanol. Let it is a component, ethanol. Now I want to make the solution. What I will do, I will add water in it. The moment I will add water in my ethanol, what will take place? Water will come in between water, or any other component you may add. It will break the H bond among ethanol. It will break the H bond. To break the bonds, energy required. So first is delta H mixing is positive. Reaction is endothermic. Energy is required to break the bonds. When water is added to ethanol to make the solution, it comes between, it breaks the bond. To break the bond, energy is required. The reaction is endothermic. Either you write delta H mixing positive or you may write delta H mixing greater than 0. When these bonds break, molecules move far away. Molecules move far away because bonds break. So delta volume increases. Delta V mixing positive. Because molecules move far away, bonds break. Because bond break, molecules move far away, there is a less force of interaction. So the more molecules can go into vapor now. More molecules can go into vapor now. Vapors increases. Number of vapors increases. Vapor pressure increases. Number 3, Pa is greater than P naught AXA. Pb is greater than P naught BXB. Same. PS is greater than Pa plus Pb. And have you noticed? Fourth point is, unlike forces are weak, like forces are strong. And number 4 is, like forces stronger than unlike. Note down it. So this is a non-ideal solution showing positive deviation. Now you can make the concept key. It's very difficult to make an ideal solution. Why? Because when two components are mixed, either the bond breaks or the bond makes. And we are talking about ideal solution where there is no bond break and no bond formed during mixing component. Delta H mixing is 0, delta V mixing is 0. So that's the reason I said ideal solutions are very rare. Most of the solutions are non-ideal. I think it is clear, but I'm giving you one question. If you are able to attempt that question only, then this topic is in your mind, otherwise not. So now I'm taking 2 questions, not 1. My question is, for that we will make graphs as well. Tomorrow we will make the graphs. Just I'm solving 2 questions now. I have taken 50 ml ethanol plus 50 ml water. This is my first question. I have 50 ml ethanol, 50 ml water. My solution volume become 100.1 ml if it is 100, 50, 50, 100. But I said my solution volume become 100.1 ml. My question is, what type of solution is it? Answer is volume increases. So answer is, it is a non-ideal solution showing positive deviation, right or wrong with me, from ideal behavior. So it is a non-ideal solution showing a positive deviation from ideal behavior because volume increases. But if I say 50 plus 50, my question number 2, if I say 50 plus 50 is 99.9 ml, after mixing the volume decreased. This means, what is it? Vice versa. Now it is a non-ideal solution showing a negative deviation from ideal behavior. Now my second question is, if I say I mix 2 components A and B, and after mixing my solution become hot. My solution become hot. I have mixed 2 components in it and my solution become hot. What type of solution is it? Answer is, when the solution become hot, this means inside it exothermic reaction going on, because solution become hot. Reaction is exothermic. In exothermic reaction, delta H is negative. So hence answer is A plus B when the solution is hot after mixing. So it is a non-ideal solution showing negative deviations. If I say after mixing the solution become cool. Cool means endothermic reactions. Exo reactions are hot and endo reactions are cool. This means if I say cold reactions, A plus B, cold solution obtained. The reaction is endo. Endo means delta H is positive. So it is a non-ideal solution showing a positive deviation. So this is all about today's lecture. Tomorrow I will draw the graph of non-ideal solutions. So when you will sit to listen my lecture, kindly bring 2-3 colored pen different, because the graph only then get clear in your minds if you will draw the graph with 2 different pen. Okay, that's the reason I've left with the graphs of the non-ideal solutions. Now this is all about today's lecture. Enjoy and like, share and subscribe my channel. after completion of this solution chapter within 4 or 5 days, I am going to start MCQ of each and every topic. Thank you.